Alright, so for my honors project, I decided to look into the geology of Arizona in a different light than I've looked at it before. And here are some pictures from Sedona when I visited. So the first endeavor that I went on was looking at Sedona. And I learned that the red wall limestone was formed by normal sedimentation, which was started by the uplift of the entire Colorado Plateau, and then erosion followed by that. And this created the Hermit Formation of sandstone. Water, as always, was the most powerful erosion force, which it always is. And canyons were also formed from the uplift, and the erosion created somewhat pointed tops on some of the rocks, as you can see right here. And everything goes back to plate tectonics as always. So when the faults moved, it formed nature in different ways. And then in Sedona's rocks, you can also see very clear layers between different kinds of sediment and different kinds of sandstone. The next place I decided to go to was the Tonto National Forest, and specifically the Tonto National Bridge. So this bridge is actually the largest natural travertine bridge in the world, and I had to look into it, but travertine is actually a form of calcite that turns from white to gray when it gets weathered. And this sedimentary rock is developed by spring water being rich in calcite evaporating. There was also a basalt cap that was formed on top of the entire formation by volcanic eruptions. So the top of the hill broke, so the cap broke, and then the faults shifted, and springs resulted from aquifers, and this formed the Travertine Dam. Volcanic activity, plate tectonics, and water were key in the formation of the Tonto National Bridge, which is why it's arched in this way, and there's still water that flows off of it. And you can see all the porous rocks from the volcanic activity. So the volcanic activity impact on nature is actually greater than I thought. It leads to very porous igneous rocks, as we can see here. They could obviously transport water pretty easily compared to a lot of other rocks that absorbs a little bit. There's a lot of poorly sorted conglomerates that are in the gap under the bridge. You can see this light, so this was when I was under the bridge. I also went to the Lava River Cave in northern Arizona, and this lava tube cave is a mile-long underground cave. It was formed 700,000 years ago, and it originated at a volcanic vent in Hart Prairie. And the formation of molten rock makes it clear that the sides of the lava flow cooled first, and then the lava trickled out of the cave, which you can see right here. So these obviously happened first, and then the lava continued, and then this hardened. And the final blast made the molten rock reliquefy and drip, making stone icicles and clumps of rocks on the ceiling. So this is when I was headed back out of the cave. This is the light, and this is the entrance. So there were a lot of rocks on the outside of it as well. Some of these look like they were set there just so it'd be visible by the public. And right here you can see the texture of the igneous rocks on the inside of the cave. Even though Arizona is a desert, it's definitely not deserted. All of this life and flowing streams and all of the nature is still very present. It's just considered a desert by definition, but that means that there's less than 10 inches of rainfall in a year. So that's not a very specific criteria. And there's constant dynamics of life that are thriving and changing in this ecosystem, which we can see by all of the trees and everything here, and all of the sites that I visited. And that's it.